Hello students, today I'll discuss about preparation of haloalkane. As we know, haloalkane compounds means Rx type compound. That means when R attached with halogen, this compound is called haloalkane. We have to prepare this type of compounds by means today's class. We'll prepare haloalkane compounds. First compound is done from alkene. What is alkene? Alkene compounds are those compounds in which carbon-carbon double bonded compound is called alkene. Suppose this is the first member of alkene compounds, which is carbon-carbon double bonded compounds. When it is treated with halogen molecule, suppose X2, in presence of one solvent, that is CCl4, depending on halogen atoms, this is called halogenation of alkene. By means we can prepare one kind of haloalkane type compounds. Due to heating, double bond first converted into single. That means single bond is exist. Now addition of halogen atom towards carbon-carbon or carbon atom where double bond was exist. Now in this case, one halogen atom, second carbon containing halogen atom. That means you have to add halogen atom at that particular carbon atoms where double bond was present. In this way, we will obtain one type of compound that is called vicinal halide. The vicinal means double bond, two nearest carbon atoms containing halogen atom, which is called vicinal dihalides. This is a one kind of preparation of haloalkanes. Clear? Now, second examples from haloalkane, that is, suppose a example is like this. In place of halogen, suppose Cl2 is given in presence of CCl4. Due to heating, this double bond converted into single CH2, CH2. Now, how many Cl? 2. This one Cl is attached with this one, another Cl is attached with this carbon atom. And we will obtain, here is Cl, here is another Cl. In this way, we will obtain haloalkane type compound. This is halo, this is alkane. Clear? Next example, suppose another alkene, propene. When propene is treated with, suppose chlorine molecule in presence of CCl4 solvent. Due to heating, this double bond converted to first single. Suppose CH3, CH, single bond, CH2. Now we have to add this Cl at that particular carbon atom where double bond was present. Now in this case, one Cl, another Cl will introduce in this carbon atom. And in this way, we will get haloalkane. This is done from alkene compounds. Second category of preparation of haloalkane from alkene, that is when unsymmetrical alkene, suppose propene is an unsymmetrical alkene because double bonded attached to different type of substituent group, that is methyl is different group, here is only a hydrogen is exists. That's why this is called unsymmetrical alkene, that is known as propene. When propene is treated with HX type reagent in presence of simple heat, this reaction will follow one important rule that is known as Markovnikov's rule. Markovnikov's rule means the positive part of the reagent, that is H, introduced at that carbon atom where double bond is exist, but number of highest hydrogen containing carbon atom you have to add H. That means positive part of the reagent goes to the carbon-carbon double bond, which is bearing highest number of hydrogen atom. So in this way we have to add hydrogen, and this is halogen attached to it, this carbon atom. So hydrogen is added to that carbon atom where number of hydrogen atom is more. Like suppose CH3, CH single bond, CH2. Here is number of hydrogen atom is more, that's why hydrogen will introduce in this carbon atom. Similarly, the negative part of the reagent goes to the carbon-carbon double bond, who is bearing less number of hydrogen atom. Here is less number of hydrogen atom, that's why this is the position of halogen. In this way, again we will obtain haloalkane type compound. This is again haloalkane. That means by means Markovnikov's addition towards alkene we will obtain haloalkane type compounds. Another example, suppose CH3, CH double bond, CH2 plus HBr. Suppose in place of HX, HBr is given. Then this reaction is again accordance with Markovnikov's rule. Markovnikov's rule means positive part of the reagent goes to the carbon-carbon double bond, which is bearing highest number of hydrogen atom. Negative part of the reagent goes to the carbon-carbon double bond, which is bearing less number of hydrogen atom. Here is only one hydrogen, here two hydrogen atom. That's why due to heating, first double bond converted into single. Then addition of positive part at that particular carbon where number of hydrogen atom is more. Here is negative part. Negative part means Br. Halogen, it will be 2-bromo-propane. This is a one kind of haloalkane. Numbering is done from either this side or that side, 1, 2, 3. That's why this is 2-bromo-propane. In this way, we can prepare Markovnikov's addition. With the help of Markovnikov's addition, we can prepare easily haloalkane type compounds. Clear? Next, suppose a reaction is given like this. Suppose unsymmetrical alkane, that is propene, reacts with HBr, but in presence of peroxide. The presence of peroxide or hydrogen peroxide or benzoyl peroxide. This is called benzoyl peroxide or hydrogen peroxide. This reaction is reversed with Markovnikov's rule, that is known as anti-Markovnikov's rule. Anti-Markovnikov's rule. This rule states that the positive part is attached with that carbon atom where number of hydrogen atom is less. Negative part of the reagent goes to the carbon atom where number of hydrogen is more. This is simple meaning of anti-Markovnikov's rule, that is from actually chapter number 13, class 11. In alkene, their properties, that means these are some uses of alkene, reaction with HBr or HX type compounds. Due to heating, again it will form single bond. Now addition of H at that particular carbon where less number of hydrogen atom. Here is less because this is presence of peroxide. This will take place accordance with anti-Markovnikov's rule because of peroxide presence or presence of peroxide. This reaction actually done like this. Halogen is attached with that carbon atom where number of hydrogen atom is more. We will get in this position hydrogen is added, or in this carbon atom Br is added. again it will produce haloalkane compound, that is 1-bromopropane. This is another kind of haloalkane. In this way, we can easily prepare with the help of Markovnikov's rule and anti-Markovnikov's rule. We will get haloalkane type compounds. Is it clear? Okay. Next example. Suppose a compound is given like this. Reaction with HBr in presence of peroxide. Due to this is a double bond, so this double bond will convert it fast into single. Now H is attached to that carbon atom where less number of hydrogen atom. Less number means here is carbon atom is exist, because here is carbon atom is exist. Number of hydrogen atom is here 2, but in this carbon atom only 1 hydrogen atom. That means less hydrogen containing carbon is this one. That's why in this carbon you have to add hydrogen, because less presence of peroxide means anti-Markovnikov's rule will follow for this reaction. Next come to this carbon atom. This is CH2, but this is containing Br. In this way we will get haloalkane type compounds. Clear? Due to presence of peroxide, this reaction will follow anti-Markovnikov's rule. Am I clear? Okay. Second preparation is done by Finkelstein reaction. Finkelstein reaction. Finkel actually prepared haloalkane compounds after the discovery of haloalkane or preparation of haloalkane. When haloalkane is treated with, according to this reaction, haloalkane is treated with sodium iodide. This is called sodium iodide. Is treated with in presence of dry acetone. It will form iodoalkane, and byproduct is NaX. This is called iodoalkane. That means Finkelstein try to prepare iodoalkane type compounds. Here X is a limitation, that is Cl and must be Br, either Cl or Br. You can put the value of X, in this case Cl and Br only. Suppose example is CH3, CH2, Br, bromoethane. This is bromoethane. When bromoethane is treated with sodium iodide, this reagent indicates this reaction is actually take place in presence of dry acetone. In presence of dry acetone, it will form a product like this, CH3, CH2I plus NaX. That means this reaction actually happen like this. Suppose this is metal is always positive, halogen is always negative. This is halogen, it is negative, but this carbon atom is always positive. That's why negative part will attack in this carbon atom, and sodium and halogen, this group will eliminate as a NaX type, but X here is Br is given. In this way, we will get iodoalkane. Is it clear? In first case, this is minus, this is metal is always positive, halogen atom is negative. That's why this I part, that means X part, is always attached to it, this positive part. In this bond will breaks and form Na and X as a byproduct. Next example, based on Finkelstein reaction. Suppose a compound is given like this. This is again bromo, 2-bromo-propane. This is 2-bromo-propane. Treated with, suppose, sodium iodide. This iodide, sodium iodide, indicates same condition, dry acetone in presence of dry acetone. That means this bond will breaks actually. This bond will breaks and form CH3, CH3 attached to it I, because Finkelstein is prepare only iodoalkane type compounds, iodo or 2-iodo-propane. This is the main product, and byproduct is NaBr. This is Finkelstein reaction. I have already discussed only 2 important preparation of haloalkanes. Next class I will discuss the remaining major 3 another types of preparation of haloalkanes. If you like the video, please share and subscribe. Thank you.